Hello everyone, welcome to the BDM channel, special topic on motor selection for SPM design. Today, we are learning the second lesson of the series, how to choose stepper motor types, models, and brands. As you can see, on the left is an automatic screw-driving machine. For this type of desktop automatic screw-driving machine, typically, the three axes X, Y, and Z all use stepper motors. Here, we have used a lithium 57 frame stepper. So, why is a stepper motor called a stepper motor? How does its control method work? Let's take a look together. A stepper motor is an open-loop control element that converts electrical pulse signals into angular or linear displacement. It rotates in fixed angular increments, called the step angle, moving step by step. So, at this point, note that if we need it to run step by step, a stepper driver must send pulse signals to drive it. Hence, this type of motor is called a stepper motor. When we use it in design applications, we can understand it more deeply. We can control the number of pulses to control its angular displacement, thereby achieving precise positioning. Simultaneously, we can control the pulse frequency to control the motor's rotational speed, thus achieving speed control. So, as you can see, this is the fundamental reason why our stepper motors can achieve both speed and position control. This is the basic principle. So, what common types of stepper motors are there? For example, in practical design applications, we commonly use three types of motors. The first is permanent magnet, the second is variable reluctance, and the third is hybrid. Now, permanent magnet types are usually three-phase stepper motors. Variable reluctance are typically two-phase. The hybrid type, however, combines the advantages of both PM and VR types. Therefore, generally speaking, the hybrid stepper motor is the most widely used type. Stepper motor. Regarding the specific types, generally, there are three common ones. First, two-phase stepper motors. Two-phase stepper motors have step angles like 1.8 degrees or 0.9 degrees. Three-phase have 1.5 or 0.75 degrees. And five-phase stepper motors have 0.72 and 0.36 degrees. Here we can see that, as the number of phases increases, the stepper motor's step angle decreases and its accuracy improves. Therefore, for many common applications, like small conveyor lines driven by stepper motors, we typically choose two-phase steppers. For applications like screw-driving machines or some robotic arms, where we might use stepper motors, and where using a servo motor would be overkill or wasteful, we can use five-phase stepper motors for the design and implementation. So, these are the motor types, and the differences in their phase count. Now, we also need to know that now that we understand their types and phases, what are their specific? Their specifications are as follows. They are not described by power rating, unlike our standard motors or servo motors, because they have a special torque speed curve. This is speed, this is torque. As the speed increases, the torque decreases. This decrease follows a curve, so it doesn't conform to a single formula, like power equals torque speed 9,550. Therefore, you can deduce from this formula that it doesn't have a fixed power rating. So, naming a stepper motor based on power is incorrect. So, how are they typically named? We usually name them based on their flange size. For example, look at this motor, right? We make them in various flange sizes. This is a 57 frame. See? That means the distance between the two mounting holes is 57 millimeters. In design applications, we have various flange sizes: 20, 28, 35, 42, 57, 60, and 86. Typically, 42, 57, and 86 are used most often. The 60 is an intermediate size. If a 57 is a bit too small and an 86 is too large, we can use the intermediate 60 size. This size is available from lithium. It's called the large 57 version. As for the 20, 28, and 35, these are micro flange steppers. These motors are typically used in very small application scenarios, for example, with very small loads, and where the installation space is very limited. Then we can choose the 20, 28, or 35 frame. These are used in some mounting equipment or small rotational angle adjustment applications. They are used more often there, right? So, this is important to know. Generally, these are the motor sizes and types. Of course, when designing and selecting, we also need to consider brands. What are some commonly used brands? Actually, domestically in China, the top names are generally Lisai and Mingji, but Yangkong, Jimeikang, and Handabao are also acceptable. Relatively speaking, Mingji and Lisai are chosen more often, especially Mingji, as its product range is broader. When we use them in design, you can prioritize selecting these first two, Lisai and Mingji. If the company has other brand requirements or is very price sensitive, you can choose other smaller brands. They are available. Of course, Oriental Motor is a Japanese brand. If specified by the customer, we might need to choose this one, which is more expensive, but offers better performance. Oriental Motor. It's important to be aware of this brand. So, these are the brand selection. Depends on company policy or customer specification. This should be chosen based on the actual situation. I'm just sharing the brands I commonly use as examples for you. So today, this lesson primarily covered stepper motor types, models, and brands. Please note, generally, the most commonly used is our hybrid stepper motor. We usually use 2-phase, and for higher precision, 5-phase, right? Remember this. Later, when we design and select, most of the time we will probably choose 2-phase motors, correct? 5-phase motors are relatively more expensive, so we select them less often. This is a point for you to understand. Well, that concludes today's lesson content. We'll see you in the next lesson.